Okay. In the second class, you were not there.
Yes, sir.
Okay. So what part, were you present while we were talking about the formation of the coal?
No, sir.
No, at that time you were not present. Okay. Let me just give you a quick recap of the concepts we have learned so far in the chapter. We learned about the need of fossil fuels. Okay. By the way, before I continue, do tell me what is the study of fossils called as? Hmm. Answer this to me. What is the study of fossils called as?
So, what is the study of?
Fossils called as. The study of fossil. What is the name of the study of fossils? That is paleontology. Okay. That is the study of fossil fuels. With the help of study of fossil fuels, we are able to study about the history of life on Earth. Huh? We are able to study how life evolved on Earth. So, with the help of this, we are able to understand that we study in the field of paleontology. Let me write it down over here. Paleontology. That is study of fossils. Okay.
Okay, sir.
Okay. Fossils. You understand now what are fossils? Basically, they are remains of plants or animals or bacteria that were submerged in the rock
Yes, sir.
materials that were preserved in the rocks over the course of
Yes, sir.
millions of years.
Decomposed.
Not decomposed, basically they were preserved actually, because if they were to be decomposed, thereby it would not be left.
Okay, sir.
Right now, okay. Furthermore, we learned about fossil fuels. So, like coal and petroleum, they are also dead remains of plants and animals now, but they converted into fuel, right? While this, for example, this fossil, this is not fossil fuel. This is just a fossil because it can't be used for combustion. It can't be used to obtain energy. So this is just a fossil. But you had coal and petroleum. They are also called as fossil fuels because they were formed from the dead remains of plants and animals. We use
Yes,
them
sir.
for various purposes like cooking, transportation, electricity production, or industrial usage or heating, like that. Even they are used in rocket propellants also. Like for example, liquid hydrogen. This is used in this is used as a fuel for rockets. Or for example, liquid oxygen, that is used for uh, that's a different example that wouldn't be counted in the fossil fuel. But since we are talking about rockets now, so thereby I gave this example too. Okay. Then while I was explaining about the electricity production, so for example, coal or petroleum would be used in the thermal power industries to heat up the water. And this water will rotate the turbine, and in return, this turbine will produce some electricity. We did a similar kind of activity here, like this. You had taken a motor, for example. This you can also do at the home. We had taken a DC motor, and we are rotating its axle with the help of our hand. Okay, no? And as the motor rotates, this bulb will glow. Getting it?
Okay,
So,
sir.
okay. We also learned about the characteristics of a good fuel. Yes, Ibrahim, how are you? Were you present, Vaiga, at that time while we were talking about the characteristics of the good fuel?
Yes, sir.
Okay, then. Then we were learning in the previous class about coal and its formation. So we learned that it's a black colored fossil fuel which is extracted from the ground and is used for different purposes. How
Yes,
it
sir. I
is
was not
formed?
there for that class.
At
Formation
the
of call. I was.
Okay, no worries. Let me just give you a quick recap of the concept. So,
Okay, sir.
okay. Ibrahim, can you explain how the coal formation took place? Yes.
Yes, sir.
Explain the coal formation.
So millions of years, millions of years ago, in like swamp, many trees died, and then they were buried deep into the soil, and this continued, and many trees uh, kept burying inside the soil, and then they got deeper into the soil where was high. Pressure was high, and heat was also high, which made them coal.
Which converted them into coal over the course of millions of years, right? See what happens. Like there were swamps like this that existed millions of years ago, and that is found even today. Like this is not a picture from million years ago now. So swamps are the areas which should be flooded with water. It would be every time it would be flooded with water. So what had happened, no? Like millions of years, they were giant trees. Trees were so big at that time. So giant trees eventually they would be following a birth and death cycle. So when their life cycle would be over, they will die right now, and they will fall into the water. And this continued for not just 1 or 2 years, but continued for millions of years. So when dead plants were submerged into the swamp, huh, and this is happening for thousands of probably millions of years, so thereby over time what happened, the plant matter converted gradually into coal. How did that happen? It was exposed to pressure and heat. So gradually, what would happen? Yes, Aisha, how are you? So gradually, what would happen over the course of millions of years? Dirt would accumulate on the body of the dead plants. Uh, Furthermore, a water body also has developed over it. So all this led to increasing pressure on this dead plant. So they were buried under dirt and water, and they were exposed to extreme amount of pressure. That is first thing. Now, initially the dead plants it would be moist. Initially, like 100 million years ago, they were not very dry, and at that time it hasn't converted into coal. So it was being it was in the procedure of being converted into coal. At that time, it was still moist, right now. So how moisture was? How do we get rid of moisture? With heat, right now. So from within the earth, it was exposed to heat also. Like we know that just beneath where the crust is over, just beneath the crust, we have mantle, and mantle and core is very warm layers of the earth, right? So the coal would be exposed to the heat coming from the mantle and core also. So due to pressure and heat, it was gradually converted into coal. So heat and pressure was one of the important geological factors responsible for converting dead remains of plants into coal. Another thing we learned that there was no oxygen here, because we know that due to the intense amount of pressure of the dirt and the water body above it, the gases would be expelled from this area. There would be no gases here, because gas being lighter intensity, it would be expelled from the soil via the cracks in the soil. Somehow it will be expelled out of the soil. Now, why we are discussing about oxygen? Because we know that if there were to be oxygen present here, so thereby bacteria would eat the dead remains of the plant, and this would be decomposed and it will mix into the soil, and hence no formation of coal would have taken place. So absence of oxygen was necessary. And also you know that whenever you push something, where you press something, thereby gas liberates out of that area. Gas is expelled from that area because gas is lighter intensity. So that was one of the things. So due to geological processes like this geological factor like heat and pressure, and due to absence of oxygen, gradually over the course of millions of years, the dead remains of plants were converted into coal. Also we learned that yes also we learned that if coal is found at more deeper level, so thereby the carbon composition is more in it, right now, Aisha? So coal found at more depth is of higher quality, while coal found at less depth is of poor quality. Then we learned about the composition of coal. So coal in the decreasing order has following composition. So carbon is of course the main component found in the coal. Then you have some amount of hydrogen, then oxygen and nitrogen. These are the composition of coal. Also, they are found in the mixed state, in the form of compounds. Getting it? Now, they are not found in the pure state.
Okay, sir.
Okay. Then we learned about the mining also. So we learned that mining is basically extraction of precious minerals from the ground, precious materials from the ground. So coal mining is done in two ways. Either via the surface mining, if the coal reserves are close to the topsoil, so thereby you can basically remove the layer of the topsoil, uh, and then you will be able to extract the coal from the surface. But in some cases, what if the coal reserves are found at very depth? It is found 500 feet below the ground. So then we have to do the tunnel mining. A mining has to be done here. Tunnel mining has to be done here. So that whether it has to be a tunnel mining or surface mining, that will depend upon the depth at which coal reserves are found. Got this now. Also, we learned about types of coal based on carbon percentage. So you have the following main type of coals. You have peat, lignite, bituminous or subbituminous, and then anthracite. So this is the type of coal in the increasing order of the carbon found in them. Like in anthracite, as you can see over here, this is the coal of purest quality, and it is also expensive than other coals. So it has a carbon content of around 86 to 97%. Subbituminous will have less carbon content in it, will around 50 to 80%. Furthermore, lignite will have less content of carbon, 50 to 70, and then peat, which is a light brown in color, which is moist. It have will have high moisture content in it. Coal carbon content percentage is just around 30 to 60%. Getting it, guys? So these were the types of coal based on the carbon percentage. Okay, now in this image over here, steam coal and graphite, they are not considered usually as coal. Graphite is not considered as coal, while steam coal is basically the vapor state of the coal. That's a different thing. So peat, lignite, bituminous or subbituminous, and anthracite. This is what you have to learn. Okay. Also, we learned about uses of coal. We have different uses of coal. Uh, Almost in every industry, it would be used. Like the not every, I would say, but 40% of the energy requirements of most of the industries are met by burning the coal. Right. Okay. Earlier, we also learned that Thomas Newcomen in the year 1712 invented the steam engine, and a steam engine runs basically a steam engine. It used the steam pressure in order to run the engine. So, in order to heat the water, coal was being burnt in the steam engine. So that was the working of steam engine. Getting it, guys? So there, what basically would be happening, like uh, steam under pressure, it would be first like kind of pushed into a cylinder, uh, and we know that as the water vapor will expand into a cylinder, the pressure in it will increase. Getting it now? And the pressure in it will increase further. That pressure will be used to push the pistons. Like pistons are the components found inside the engine. Any vehicle that you see, any kind of vehicle that you see, how does that move? That basically moves with the help of pistons in them. For example, when you look at a car engine or when you look at a motorbike engine, anything, they have a structure in them called as piston. Yes, Ibrahim, you know what is a piston?
Yes, sir.
Like this is what I'm talking about. This is the first image. Hmm? You guys would have seen it somewhere. Animation in YouTube or somewhere you'd have seen it. So these are the pistons found in the engine. All the engines of different vehicles, all of them have got this piston. So it is due to the movement of the piston that it will move. Now, how does that happen? See, for example, Nowadays, the pistons work. Uh, in order to run the pistons, we make use of. We would be using petrol or diesel. But earlier, in order to move these pistons, steam would be filled into it. Steam would be filled into it. So with the help of steam, the pistons would be moved. Anyways, let's get back to the topic. Then we were learning about destructive distillation of coal. Before we were learning about this concept, we did revise about the concept of distillation, basically what distillation is. Destructive distillation of coal, we learned about that topic, but we learned about distillation also. So distillation, like in class 6 standard, like in the separation of substances, that chapter you would have studied about various methods of separating mixtures of two liquids. Or you had would have learned about various techniques of separation. You'd have learned about winnowing, threshing, decantation, evaporation, condensation, crystallization, all that you would have learned. Right, Aisha, Ibrahim, Waiga, all three of it on your cameras on in the class. Then distillation is a separation technique used to separate liquid, the solvent from a mixture and keep the liquid part. Say for example, you have two liquids A and B, their boiling temperature is different. For liquid A, it's 160, for liquid B, it's 120. Let's say we want to separate them. Okay, na? So we would raise the temperature up to 120 degrees Celsius. So liquid B will convert into vapors. It will go into this tube. This tube is being cooled down by pouring cold water on its surface. Right now. So as the vapor of liquid B will pass inside this, it will cool down. So condensation is happening here, isn't it? In the first step, you have boiled it. In the second step, you have cooled it down. So from this tube, drops of liquid B will fall down. So you would have separated the liquid B in this manner. So that is the whole concept of distillation. Getting it, guys? Yes, Ibrahim, Waiga, Aisha, is that clear to all of you? So that
Sir,
is
Yes,
can you
sir.
please explain it again?
okay. See, distillation is one of the separation technique where you can separate two liquids, liquid A and liquid B. Both are miscible, meaning that both of can mix very well, but you want to separate the two liquids. Right now, although I in this image I have marked them with different colors, but it was actually not having these two different colors. Initially this image hadn't these two different colors. Okay.
Okay, sir.
So liquid B and liquid A, like two liquids will have different boiling temperature, of course. Uh, for example, you have a water, or you have, for example, any other liquid, let us say milk. So those two liquids have different boiling temperature. Getting it, guys? So
Yes,
thereby
sir.
you want to set, let's say, separate liquid B. So you would heat it. Let's say its boiling temperature is 120. For liquid A, it's 160. So how about we increase the temperature to 120 degrees Celsius? So thereby liquid B will convert into vapor. It will convert into gas. So it will evaporate from here and it will go into this tube. And here you are cooling the vapors of liquid B. And as it cools down, it will convert into liquid and will fall down into this tube, into this glass tube. And hence here you have separated the two liquids. Okay, now what about liquid A? Liquid A will be left in this glass. No need to raise the temperature to up to 160. Getting it now? That was the concept of distillation basically. So I thought
Got it, sir.
it would be required for you guys to revisit that concept, but that is not very much related to destructive distillation of coal. Okay, no, only some part of it is related. So why this animation? We got to learn about that. Hmm? Have a look at it animation real quick.
Laboratory method of
One
destructive
moment, let me just clean this.
Laboratory method of destructive distillation of coal. The process of heating coal in the absence of oxygen to obtain useful products is called destructive distillation of coal. When coal is heated strongly above 1000 degrees Celsius without air, it produces many byproducts. The main byproducts are coke, coal tar, amino acid liquor, coal gas.
So the third one, amino acid liquid, that is not important for you guys. Okay, now that you don't have to
Okay,
study.
sir.
So you have to study about coke, coal tar, and coal gas only. That is only important.
Let's understand the concept through experiment. Objective of the experiment is destructive distillation of coal. The materials required are two hard glass test tubes marked A and B, delivery tubes, clamp stand, burner, rubber stopper, pieces of coal and water. The procedure: take small pieces of coal in test tube A. Test tube A is fitted with a rubber stopper carrying a delivery tube and is clamped to the stand. Test tube B, containing water, is clamped vertically to the stand. The burner is lighted and the test tube A is heated first gently and then intensely. The gas liberated by heated coal passed through the water in the test tube B. You will observe black coal tar collected at the bottom of test tube B. The ammonical compounds formed.
Okay. So far in the animation in this video, what we have saw that this sample of coal which is being burned in gas A, it is being burned in the absence of oxygen, in the absence of air, more specifically oxygen, right? So while it is being burned, so a gas will be coming out of it. Okay. So the gas will pass by this bent tube, and this bent tube is being dipped into this water. It is dipped inside the water. Okay. So the gas that is coming out of this test tube, it will be first of all bubble into water. It will be bubbled, like whenever you exhale air via a straw into water. When you exhale or when you blow into a straw into the water, bubbles will be formed, isn't it, guys?
Yes, sir.
Right? Okay, so what we see here, that this is being bubbled into it. Getting it? So thereby the hot gas that would be coming out of it, it is being cooled and bubbled through this water. The purpose of putting water into it is that you are cooling it, and also this water is being bubbled. You guys understand what I'm trying to say, right? So this hot gas, it will be bubbled and it will cool down. And later on, you'll observe that a black thick liquid will sediment. It will deposit at the bottom of this test tube that you are going to call as coal tar. That you're going to call as coal tar. So it will deposit. Getting it now? Okay. Now continue further.
Will dissolve in water in black coal tar collected at the bottom of test tube B. The ammonical compounds formed will dissolve in water in test tube B to form ammonical liquor.
Now the ammonical liquids now. The ammonical compounds, like compounds of ammonia, it is soluble in water. So it dissolves in water. Okay, now coal tar, it's not soluble in water, thereby it settle at the bottom. Yes, Aisha, it's settled at the bottom. Getting it now? You, Viger and Ibrahim, you also.
Yes, sir.
So coal tar, it is not soluble in water, thereby it dissolve at the bottom of the beaker. But compounds of ammonia, they are soluble in water. Like this gas, this gas now, it contains compounds of ammonia also. So the compounds of ammonia found in that gas, it is soluble in water. So thereby it will dissolve in water and will form ammonical liquor. It has also got some use, but that is not relevant for this class. Okay.
Coal gas, insoluble in water, escapes through the side tube. It can be lighted at the end of.
So guys, tell me that this coal gas is escaping from the other tube. It comes out via the other tube. So it must be soluble or it must not be soluble in the water.
It's not soluble.
Not soluble.
That is the reason why it came out of it. Okay. And this is combustible. It is very much inflammable. As you bring a lighted matchstick near this, it will catch fire. You got this now? Okay. But what about this coal sample that we initially took? It converts into, yes, Ibrahim, you tell me, what does it convert into?
Coke.
That converts into coke, which is almost purest form of carbon. Okay, no?
Yes, sir.
Okay. Now let us learn about the uses of these three components which we have obtained from destructive distillation of coal. Why again, Aisha? You guys also turn your cameras on in the class. See, the only reason why I'm repeating this many times in the class now, I keep on repeating this because it has been told to me from the Learnivio team that it is important for you guys. Also, I would have personally suggested to you guys that for a better interaction, turn your cameras on in the class. Also, one another thing is that they would be monitoring this and they would be reporting once your report cards would be prepared, they would be reporting this to your parents. So it wouldn't be a good review. Okay. So talking about coke, so you were obtaining in which test tube? Test tube A or test tube B? Okay, Vaiga, no issue. If you have that problem, no worries. Yeah, coke, you get it in test tube A now when you were heating it in the absence of air, isn't it, Aisha? So it's a tough, porous, and black substance. Have a look at this. This is how coke looks like. It is tough and it is porous. Porous, what does the term porous mean? Porous means that water or other liquid can pass through it. Getting it? And it is almost pure carbon. It is almost pure form of carbon. It would be particularly used in extraction of steel, particularly used in manufacturing of steel and in extraction of various metals. So coke is used in extraction of many metals and manufacturing of steel. But the thing is that why do we use coke there? Anyone thought about this? Why do we use coke in manufacturing of steel? You guys know about steel, huh? Like steel is a alloy, no? Yes,
Yes,
Vaiga?
sir.
Huh? So steel is a alloy, but what is its composition? It is basically made up of iron and carbon, no?
Yes,
When
sir.
iron and carbon are combined in different proportions, when they are combined together, thereby steel is formed. Okay, then one question is that why carbon is added to steel? How is it beneficial? Anyone thought about this? Basically, what happens, like iron, you know about iron, right? Iron is used in different things. It is used to make bridges. It is used to make different machines and machine components, etc. Now, nowadays, what is happening? We are preferring to use stainless steels also. Why? Because addition of carbon, like carbon, where you're getting from this coke, which is almost a pure form of carbon. Okay. So when carbon is added to iron in order to make steel, it will significantly affect the mechanical properties of the iron, meaning that strength and hardness will increase. Strength and hardness of the iron will increase. Getting it, guys? So in order to
Yes,
increase the durability To make it more stronger, carbon is added. Got this now?
Yes,
even
sir.
even like smaller objects, for example, the iron needle that that we use in order to stitch the clothes, is that pure iron? That is actually stainless steel. Huh? Or the scissor blades, that is also stainless steel. Got this now, guys? So addition of carbon in it increases its durability, makes it more harder. So it is used in manufacturing of steel. So steel, you should know that steel is made up of iron plus carbon. So hope that it is clear. Okay, any questions in it?
No, sir.
No,
So
sir.
that is uses of coke. Now the processing of coal to get coke also yields coal gas also. When this is being processed now, as you saw in this activity, while this was being processed, this coke, thereby you were getting coal gas also. We should be learning moments later. Then let us learn about coal tar. What is this coal tar and what are its uses? So it's a black, thick liquid which has got a very unpleasant smell. It has a it is a black, thick liquid which has got very unpleasant smell, right? And that this is the same liquid that was settling at the bottom of the test tube B. Remember, right? Okay. Now it has several uses. Talking about coal tar, like it is about a mixture of 200 different substances. It is a mixture of about 200 different substances, so thereby now it has got several uses. For example, one of the uses of coal gas is, like for example, it would be used to manufacture certain kind of medicines. There it will be used for manufacturing explosive materials. There it will be used. Getting it, guys?
Yes, sir.
Okay.
So perfumes.
In making perfumes also, there also it is used. Not this, there also it will be used. Or for example, it will be used to make like this what do we say, like we have this mm, naphthalene balls. You guys would have seen naphthalene ball or would have used it. It is used in house, so it's in order to kill the moths. Yeah, usually people earlier, what they would be doing in order to keep their clothes safe from insects, like clothes can also be can be damaged by the insects. Hmm? Different kind of insects would damage the clothes, so in order to protect the clothes from damage by insects, this would be kept in the clothes. For example, you have like cloth moths are particularly found there, or carpet beetles are there, termites are there, uh, or cockroaches are there. So in order to keep them away, this naphthalene ball is used. So naphthalene ball is also manufactured using coal tar. uh, or synthetic dyes are manufactured using this coal tar. Certain kind of plastics would be manufactured using this. Roofing materials are manufactured using this. Then we have got photographic materials are also there that are manufactured using the coal tar. You guys understand what are photographic materials, right? Yes, Ibrahim, you know what is photographic material? Basically,
Like
uh,
print-
light.
printing and
Mhm. They are basically
printing pencil.
Mhm. They are basically light sensitive recording materials. Like earlier, you'd have seen in the older cameras, photographic films were used. You guys, as a kid, you guys would have seen this maybe, but we saw this earlier. It was more in used. This photographic film. Anyone saw this?
Yes, sir.
Yeah. Yeah. So in the manufacture of this photographic film, also coal tar was being used. Although this photographic film is no longer used. Okay, na? Although it is no longer in use. So there also it will be used. So let us quickly summarize. What are the different uses of coal tar so far we have studied? So we learned that it has got a rich composition, like around 200 different substances are found in it. So we can obtain different kind of products from it, like medicines. Certain kind of medicines would be manufactured, explosive materials are manufactured, naphthalene balls are there, perfumes, synthetic dyes are manufactured using it, paints are manufactured using this. You have plastics, you have roofing materials, then you have this photographic film also, that is also manufactured using the coal tar. Another important use of the coal tar is that although it was earlier in use, but nowadays we use bitumen. So earlier roads were metalled using the coal tar. Okay. So the question is that why roads were metalled using coal tar? What property does it have? Huh? So the thing is that it has a good viscosity. Viscosity, you guys understand? Yes. Earlier, this coal tar, it was used in road construction. Hmm. But what happened, due to several research, it was found that it was harmful for using it as a road construction material. Huh? Because it has uh, a thing called as human carcinogenic pH. It has a thing called as human carcinogenic pH. So that is not good for the human health. Getting it, guys? Which is basically found uh, to be one of the causes for cancer. Getting it? So it has human carcinogenic pHs. So thereby it lead to increased incidences of like lung, skin, or different kind of other cancers are associated with it. So it some research showed this, although it was not eventually proved, but some of the research showed this. So gradually, what happened? People the use of the coal tar as a road construction material, it was discarded. Getting it, guys? So thereby now
Yes, sir.
bitumen is used. Bitumen is nowadays used right now. Furthermore, moments ago I was talking about what was the property of this coal tar because of which it was used in the making of roads. Hmm. So the thing is that the coal tar had excellent adhesive property. Adhesive property, you guys understand about adhesive property, right? So say you have two pieces
Yes,
of
sir.
stone. No, so you have two pieces of stone. So using the coal tar, they could be joined. They could be joined. Getting it? No? So it acted as an adhesive material, just like you have different kind of gums which we use to stick papers, stick different materials. Getting it, guys? So it also has an excellent adhesive property. Furthermore, it was resistant to oil. It was resistant to oil. So because of these particular properties, the coal tar is used. Getting it? So in the road construction, what do we do? Basically, all the rocks are joined together. That's how the roads are constructed now, right, Vaika? So
Yes,
coal
sir.
tar, which was adhesive, it was used. Okay, but nowadays we switch to use of bitumen. Okay, so that's all about coal tar. So if there's any question in it, please let me know. Yes, you guys understood this?
Yes, sir.
Okay. So coal tar, it's a black thick liquid which has got a strong and unpleasant smell, right? Okay, and we learned that it is very valuable because it serves as a starting material for making various products like medicines, explosives, naphthalene balls, and many more. Okay, how are we obtaining it? Via which process it is obtained?
Destructive distillation of coal.
Hmm. Why destructive distillation of coal? Right now,
Coal.
good. Okay. Furthermore, let's learn about coal gas. Okay. By the way, have a look at this image. This is that of coal tar. Here you can see over here that it is being used as a treatment for dandruff also. The coal tar, as I told you, it will be used in as a medicine also. So coal tar can be used to cure dandruff problems also. Getting it, guys? Not in the raw form, but it has to be processed and several other things are mixed into it. Got this now, Aisha, Ibrahim, Waika? Then for
Yes,
metalling
sir.
of roads also it is used, was used, we would say. Metalling of roads. So earlier it was used. Here you can see it is being used as a paint. Got this now? Okay. And this here is being showed how you get coal tar, okay, which we learned moments ago. Okay. Then what about the coal gas? So coal gas is also one of the component which we obtain from the destructive distillation. So this is byproduct of coal to get coke. Like here, why we are calling it as byproduct? Because you guys know that the main product that is obtained in the destructive distillation of coal is coke, basically. This is the purest form of carbon. So this is more valuable. This is very much valuable. So in the process of obtaining coke, we get coal gas also as a byproduct. Got this now? Coal gas is also obtained apart from coal tar also. Coal gas is also obtained as a byproduct. Let us learn about its property and what are its uses. So coal gas, earlier it was used for street lighting. Earlier, like in London, it was used for the purpose of street lighting for the first time in the year 1810. And then in New York also it was used in the year 1820. So at that time, this coal gas was used for lighting the street lamps. Okay. But mainly nowadays we use it to obtain heat and not as a light source. So it will be used in the industries as a fuel, because nowadays we have got better alternatives for street lamps. We have light emitting diode bulbs, we have LED bulbs are there, which consumes far less energy than that would be consumed by those kind of street lamps which were running using the coal gas. Got this, guys? So earlier this coal gas was used for lighting the street lamps, but nowadays it is used in the industries. So hope that is clear to everyone. Now let us learn about what are hydrocarbons. By the way, here the topic coal has been finished. If you guys have any questions regarding that, please let me know. Yes, Aisha, Waige and Ibrahim, any questions?
No,
No, sir.
Okay. Now let us learn about what are hydrocarbons. So basically, hydrocarbons are those compounds that are made up of hydrogen and carbon. That is made up of hydrogen and carbon. Got this now? So it will contain only two types of elements, namely carbon and hydrogen. Got this so far? Let us now learn about what are some examples of hydrocarbons. So for example, methane. Methane is example of hydrocarbon. Or you have, for example, you have some other examples like butane or hexane. These are some of the examples of hydrocarbons. Now, the reason why we are studying about this, the reason is that whenever fossil fuels would be burnt, whenever coal is burned, whenever petrol is burned, or some other fossil fuels like natural gas is burned, so thereby it will release hydrocarbons. It will release some hydrocarbons. Okay. So on burning of the fossil fuels, compounds like methane, butane, and hexane, which are hydrocarbons, they are produced. Is that clear to everyone or not?
No, sir. Can you repeat again?
Okay, sure. Say you have coal. When this coal is being burnt, okay, so thereby it will release gases of methane, like it will release CH4, that is methane. So methane gas will be released here. Getting it? So just like this, various other hydrocarbons will be released. So when we burn coal, various hydrocarbons are released. Just like this, butane will also be released. Getting it, guys? Butane is released, or hexane is released. So hydrocarbons are basically compounds made up of hydrogen and carbon. Got this now? Okay.
Yes, sir.
So hope you guys are able to understand this topic. Not that much difficult, I believe. Hmm? Yes, Aisha, you
No,
getting
sir.
it? So that is the thing.
Yes, sir.
Mhm. Now I have one question to all of you. Like, what will happen if all the coal reserves were to get depleted from Earth? What would happen? Like, if coal and petroleum, for example, talking about coal reserves, what would happen if coal reserves were to get depleted? Yes.
Most of the industries will not be
Mm. Most of the
Transportation.
Mm, yes,
Mm,
transportation will be difficult,
yes, sir.
and
Industries.
mainly industries would be impacted right now.
Yes, sir.
And what else? See, a lot of our energy requirements are dependent.
medicine.
Yeah, like from the processing of coal, we get certain kind of medicines also. Very good. That will also be impacted right now.
No electricity.
No electricity. We won't say no electricity, but we know that a significant amount of electricity is produced by burning coal. So production of electricity will become difficult right now.
Yes,
So
sir.
basically what happens, we see that coal, first of all, it is being used as a fuel. Not just as a fuel, but we are obtaining various products from coal via its destructive distillation, like you obtain coke, which is used in the manufacturing of the steel. It has got various other purposes as well. Then you have um, coal tar. From this, you obtain several types of products. It is used as a starting material in the preparation of certain kind of medicines, explosives, naphthalene balls, and whatnot. Right now, so that too would be impacted. We are getting coal gas also, which is also used as a fuel, right?
Yes,
So
sir.
it would become very much difficult for us to produce energy to produce energy and to obtain these products. So hence, we must be using coal in a very efficient and a very judicious way. Getting it now? Okay. By the way, we say that at the current rate at which we are using the coal reserves, it is said that it is enough for the next 100 years. But the research says that it will not even last for another 100 years. It will be not sufficient to last for another 100 years. Getting it now? Because it takes
Yes,
millions
sir.
of years for the formation of coal. If they are getting exhausted, so thereby that would take another million of year to take to form. Getting it now? So thereby it will probably last for around like 30 or 40 more years, not more than that, I believe, right now. So thereby we need to find other alternatives like solar energy or other energy that would be renewable. Getting it? Furthermore, here I have written the substances that are released when coal is burnt, right? Also, the amount in which these things would be released, it will vary from coal to coal. Like in anthracite, less amount of carbon monoxide, or less amount of sulfur dioxide, nitrogen, or lead, or arsenic, or mercury will be released. The coal that is of poorer quality, it will release more amount of pollutants in the air, obviously, isn't it? So usually when we
Yes.
burn the coal, these are the things that are released. Carbon dioxide is released, carbon monoxide is released, sulfur dioxide, nitrogen is released, lead, arsenic, mercury. So these are the substances that are released on burning of coal. Is that clear?
Yes, sir.
So hope that is clear to everyone. Also, we know that gases like carbon dioxide. This is a greenhouse gas now.
Yes,
So
sir.
when we burn more amount of coal, so thereby it will further lead to global warming. Right. By the way, carbon monoxide also helps is also one of the causes of global warming, by the way. Then sulfur dioxide, and if you have nitrogen dioxide, hmm, so sulfur dioxide and nitrogen dioxide, these are the leading cause of acid rain. Getting this, guys?
Yes, sir.
Lead, arsenic, they are also very harmful for the human body. Uh, Anyone ever thought about this, that how lead and arsenic are harmful for humans? Yes, they are harmful to us in a various ways. Examples: if someone like, for example, it has been in such some studies, like if some people, although not everyone, like if some people are uh, exposed to arsenic for a very long period of time, so it will lead to various health problems, like it can cause heart disease, it can even lead to cancer of the lung or skin or liver. Getting it? For example, in certain countries we see that water has got higher concentration of arsenic. In some countries water has higher concentration of arsenic. So how does that impact them? So thereby it will lead to several diseases in them. Getting it, guys? Or if the concentration of mercury in water is high, that is also known to cause several problems. Like mercury is a toxic metal, isn't it?
Yes, sir.
If somehow people were to uh, if somehow people are exposed to this mercury, so that is going to cause to several complications, right? Okay, if children are exposed to arsenic for a long period of time, so thereby it will lead to several problems, like their physical growth will be reduced, like that. So hope you guys are understanding what I have been trying to say. Okay. Okay, now in this answer question, this one and this one, you guys answer this in the chat box. This is question number 1 and question number 2. The first two we'd be discussing after having learnt about petroleum. Yes, Ibrahim, what is the answer for the first one? Vaiga, Aisha?
Sir, in the chat box, right?
You can answer in the class as well. Vaiga, how can it be? Think of the answer once again. By the way, all of you have to answer on this ID only. Okay, no? Ibrahim, for the
So what?
first, what have you answered for question number 1? It is actually not correct. Aisha,
Sorry, sir.
okay. Aisha, what answer you have given for 1? No, that is not correct, Aisha. Read the question and look at the options. Ibrahim, what have you answered? Yeah, your answer is correct, Ibrahim. Good. The second one, what you have answered? Yeah, Aisha, your answer is correct. Ibrahim, your answer is also correct. Yeah, I got it. Yeah, Vaiga, no, it is correct. Okay. So we know that fossil fuels, they are formed naturally, while coke is obtained from destructive distillation of coal. Right now. Good, everyone. Okay. Answer this question number 3, question number 4, 5, and 6. Okay, try to answer it before the class ends. Try to answer it as quickly as possible. Okay, how about I assign the questions, huh? Ibrahim, you answer this question. Vaiga and Aisha. Question number 6, anyone who knows this can answer. Yeah, in the class only. No need to write in the chat box. Answer in the class. Yes, Vaiga, Aisha, Ibrahim.
Sir, can I answer my question?
Yeah, sure.
It's coal tar.
Yeah, that is cool. Very good. Yeah, Ibrahim, you have answer for question number 6. That is correct. Very good. Yeah, for the first one also you were required to answer. Aisha, waiting for you answer.
Option A.
Option A. No. Coal is classified according to.
No, sorry, option D.
Option D. Good. It's carbon content. Yeah, Ibrahim, such resources which can be continually replenished are called as. We call them exhaustible, inexhaustible, non-replenishable, or natural resources. See, how can natural resources be continuously replenished? Not all of them. Like forests are natural resources. For example,
Yes,
yeah, forest of wood is also a natural resource. Coal is also a natural resource, but they are not being continuously replenished at that rate. Or petroleum. So, such resources which can be continually replenished. So they are called as inexhaustible. No, that is not going to
yes, sir.
exist. Like for example, okay, no worries, Ibrahim. So, like for example, water, which is a natural resource, it is evaporating from the water bodies and vegetation, but it is being continually replenished by the water cycle, like that. Got it? Getting it now? Okay. Or just like, for example, we are using soil. So, soil, how it is being replenished, like the weathering of